Hi friends, this is Denario Research and welcome to my new Codius project video. Today I'll show you how to use Interledger payments in Codius contracts. In one of my previous videos I showed you how to implement XRP payments in Codius contracts. As example I used a website where you can order pizza and pay with XRPs. If you did not watch that videos, so I highly recommend you to watch them first before moving further. On the backend, our smart contract had just two modules. One of them was responsible for managing payments and another one was responsible for issuing refunds. But this simple architecture has some security issues. Let's talk about them in details. When you order something online, you provide delivery address. Typically, this is the address where you live or where you work. Also, when you pay with XRPs, you disclose your XRP address, and some website manager can see the amount of XRPs you own, and they already know where you live. So for you, this may be some physical security issue. On the other hand, when we implemented refunds module, we had to hardcode XRP account secret into contract's source code and upload this contract to Codius host. But Codius host administrators can see contract source code. That is why we had to upload our contract to host we have control over. But nevertheless, if access to Codius host is not properly configured, it may be hacked and your funds may be stolen. That is why we need a solution that allows bidirectional payments without exposing accounts' publics or secrets. That is where Interledger payments become helpful. This model works similarly to the way how Codius hosts are paid. Both parties should have running money D instance, which is linked to their XRP accounts on the one side, and LP connector on the other side. This LP connector allows them to communicate with each other and send payments. Of course, running money D instances, connecting to ILP connectors, and so on in order to order pizza looks a bit complex, but I believe this complexity will be resolved in the future. Per my opinion, sending Interledger payments today looks similarly to sending emails 25 years ago. Let's look at Interledger architecture. Like TCP/IP stack, it has multiple layers: application, transport, interledger, and ledger. Each layer has its own function. Application is responsible for receiving account discovery, amount negotiations, selecting proper transport protocol, and so on. Transport protocol is responsible for payments delivery. Also, it encrypts application data on the sender side and decrypts it on the receiver side. Transport layer splits application data into multiple packets, and Interledger layer is responsible for forwarding and routing these packets from sender to receiver through multiple or one Interledger connector. And finally, ledger layer is responsible for moving packets from sender to connector and from connector to receiver. In our case, this is XRP ledger. If you run Codius host, you are probably already familiar with most of these layers and have them up and running. But in order to accept payments in application, we need to implement Simple Payment Setup Protocol. Simple Payment Setup Protocol comprises of four components: client, which is responsible for sending payments; server, which receives payments; endpoint, which is analog to destination address; and stream module, which provides transport layer for payments. We can have two types of endpoint. The first one is payment pointer, which starts with $, or smart contracts URL, like in this example. In this video I'll make a demo how to send payment directly to payment pointer. Also I'll show you how to send payment to smart contract, and this smart contract will redirect payment to predefined payment pointer. For this demo I'll use two of my Codius hosts, Codius 2 and Codius III. Both of them are running MoneyD instance and are connected to ILP connector. Codius II will send payments and Codius III will receive them. In order to receive payments, we need to install ILP SPSP server. So let's do that. npm install -g ILP SPSP server and of course unsafe permissions. And hit enter. Well, SPSP server is already installed and we can launch it with command ilp SPSP server, and if you run this command without any keys, it will generate some random payment pointer, or we can specify payment pointer with command subdomain. And here will be your subdomain, but for now let's use randomly generated pointer. Okay, server is running, it's listening some port, and we are waiting for payment pointer. And here it is. This is our payment pointer starting with $sign. This payment pointer can be unique invoice number in our XRPizza application. So let's leave this server running and switch to Codius II. In order to send payments, we'll install ILP SPSP client. So let's run npm install -g ILP SPSP and unsafe permissions. Unsafe permissions and hit enter. Okay, we are ready to send payments to our payment pointer. As a currency we'll use XRP, and let's send 100 drops to Codius III server. In order to do so, let's run command ilp SPSP send. Then we need to specify receiver / and copy our payment pointer name with $sign. Paste it here and amount 100 and hit enter. So it's paying 100 drops to this payment pointer. So process may take several seconds depending on your network. So I'll pause the video and we'll wait. Finally, payment was successfully sent, and on the server side we see that Codius III server, actually SPSP server, has received packet for 100 units, so the amount we plan to send. You can easily add SPSP server into your smart contracts application. So when user gets to checkout page, application launches SPSP server with invoice number included into subdomain and listens to payment. Now let's try to send payment to our smart contract, and that smart contract will route payment back to our payment pointer. For this demonstration, I'll use article written by Ben Sharafian. It is called Program with MoneyD on Codius. In this demo, we'll deploy two images in one smart contract. So the first image is LP SPSP server, so it will listen payments to the smart contract, and another one is LP SPSP spender. This spender will split payment into smaller chunks for 10 units and will send these 10 unit packets to our payment pointer. So let's create Codius JSON and Codius vars.json files. Well, here is our Codius.json file. I have simply copied manifest information from the article and pasted here without any changes. And let's look at Codius vars. And in Codius vars, I have replaced Ben's payment pointer with our payment pointer that is running in Codius III. Okay, let's queue it and deploy the smart contract. Codius upload, and let's specify host. It would be HTTPS Codius. Let's deploy in Codius Denario Research XYZ Denario Research XYZ and hit enter. So deployment may take some time. Yes, we'll deploy it. And contract is uploading. Well, contract was successfully deployed. We have its URL, and let's send payment to this URL. Let's copy it. LP SPSP send receiver. Here we provide our URL and again amount 100 and hit enter. Okay, we have error. So let's try to figure out it. Oh, I forgot to specify amount. So let's type 100 and run this command again. So payment was successfully sent, and let's look at Codius 3 side. It has received already 10 units, so first 10%, another 10 units, and so on. So it will receive 10 times for 10 units. So let's pause the video and wait for completion of this payment. Finally, we have received payment. 100 drops, 10 packages with 10 units or drops in each package. This is how easily you can use simple payment setup protocol in your applications. Thumbs up if you like this video, subscribe to my channel if you want more videos, and leave your questions in the comment section below. Bye!